There's a common idea in finance that goes where there is volatility, there is opportunity, and with greater volatility goes greater returns. And this isn't always true, actually. But let's say we have that hypothesis and we're saying there's an inefficiency in the crypto market and we want to use volatility as a measurement of returns. This is the way I would go about determining whether that hypothesis is true. We would use this spearmanr package in scipy to calculate whether or not that hypothesis has a statistical significant correlation. And let's go through it. And I've done this in other videos using different commodities like electrical price in the tri-state area. I've used this on stocks. So it's time we use it on crypto. So what we're going to do is get everything that we need, and then we're going to download the data. You can see I just grabbed a bunch of different cryptos off of Finance. This is what it gives us. We need to rearrange this data, and we do that by stacking the date and ticker. We set that ticker as the index. We reorder the levels when we drop the duplicates, and this is what we get now. Cool. So now we have, here's our Binance, our date, open, high, low, close volume. Amazing. So in this instance, we're going to use the Parkinson volatility, and the Parkinson volatility doesn't just use the close over a window, a rolling window. Instead, we're using the average between the high and the low, and we're taking the log of that and applying it to basically our overall trading days, and that calculates what our window is going to be, et cetera, for our results. We apply it, blah, 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 blah. Anyway, this is just like a calculation of the Parkinson volatility. You can read up on more of that on your own. But it's basically saying there's more information between the high and the low price data points to suggest that there's volatility. There's both volatility in the day in the price because there's a high and low, but there's also volatility of that high and low across time, day over day as well. So you're trying to find the average of that on a rolling window for every trading day. Cool. We apply that to our data frame for each ticker. I just grabbed a random sample, and you can see for XRP, our volatility is negative 0.6. We do this for the lags. So we calculate return, which is pretty simple. We just take the close and we make the percent change across the lag time. So we have 1, 5, 10, 21, 42, 63. This prevents data leak. And after we calculate the lag, we have our targets, which shifts back the lag calculation to the row where it was calculated for, if that makes sense. So we have our, let's see if it'll make sense with this guy here. So you can see that we calculated our returns for here as negative 0.059, but this calculation actually occurs for the target of this row here because we're doing a one-day return, but that one-day return is the target that we are calculating. So it just shifts everything back by the lag that we calculated the returns for. Great. So we're saying with this volatility, which is 0, you should get this target return of that. Cool. So now we do our joint plot. Our target is the one day. The volatility is the volatility metric. And the Spearmanr correlation calculates whether or not there's statistical significance between this metric of volatility to this target date. You can see it's 0.009, which is extremely low. And if we look at the graph, you can totally see why. You can just see that the distribution of returns to volatility is just 0. Like there is no like no returns based on volatilities with this. Like it's not even, it's like barely even existent. But that's just one day. What if we looked at 42-day return targets for volatility? And you can see it's actually negative 0.03. So it's actually the other way around. The less volatility you have, I don't know how you get negative volatility, but That might be something I have to look into. But basically, it's saying the less volatility you have, the more returns you're going to get on this 42-day target. So in this case, we have to reject the idea that in the crypto space, volatility is an indication of returns for a 1-day return or even a 42-day return. Cool. If you enjoyed videos like this, consider downloading this code in the description and heading over to this link. You can give me a one-time donation there. If you so feel like it, you don't have to, no pressure. It just helps me avoid taking sponsors. It avoids me selling a course or starting a Patreon, all those things that annoy me about YouTube. So yeah, I would appreciate it, but no pressure. I will see you guys in the next video and have a good one.